Okay, I'm going to have to go through this run through again. Due to the sound quality, there were people drilling in the building, so I'm going to have to whiz through this again. Okay, so this paper is a Year 10 end of term test, yeah, and obviously it's on physics, and it only includes the first 3 topics, so it's really useful if you want to go back and revise the Year 10 first 3 topics, which are all big topics, and if you don't understand these, you're going to be very disadvantaged in your GCSE. It also focuses on calculations a lot, which a lot of my students find easier, and you need to make sure when you're doing calculations that you need to change any prefixes like kilo, mega, etc. into standard form like 10 to the 3, 10 to the 6, 10 to the 9 or 10 to the minus 3 in your calculations to avoid losing marks. Okay, so we're going to go through it as quickly as possible. And I'm going to highlight it. Student did an experiment to determine the acceleration due to gravity using this apparatus. Okay, so he basically dropped a steel ball inside a transparent tube, yeah, and he measured the speed using a light gate A, the black line there, so it kind of detects the movement and measures the time it takes to go through, and from that the computer has the data needed to work out the speed, and then the speed at light gate B as it's fallen all that distance. So as it falls this distance from light gate A to light gate B, and he also measured the time it took to go from light gate A to light gate B. Okay, so basically that's what the apparatus shows what he did, yeah, and here's the method. He connected both light gates to a data logger, so it's recording the data for him, dropped the steel ball from rest, yeah, at the top of the tube, but then recorded the speed at each light gate, yeah. He also had to measure the time from light gate A to light gate B. And here's the data that was recorded by the data logger. The speed at A, 1.45 meters per second. The speed at B, 4.2 meters per second. So that gave the difference in speed V minus U. And if you put those numbers in, you get a difference of 2.75. The time between A and B is shown here as 2.86. And they want you to show that the acceleration using that data is approximately 9.6 meters per second squared. In other words, calculate the acceleration. So the acceleration is equal to the change in velocity over the time taken. So you basically put this data in this equation, 4.2 minus 1.45 divided by the time that they've given you, and you then get 9.62 meters per second, which is approximately 9.6 to 2 significant figures, and the unit is given for you, so you don't get a mark for the units, but you get a mark for the calculation and getting the answer to show that it's around 9.6. Then you've got to explain why the student's value that they got, 9.6, is lower than the accepted value for gravity, yeah, which is 10. Well, it would be lower, well, I've written could, but it would be lower because of frictional forces like air resistance, and also, if you remember, he dropped the steel ball through the plastic tubing, so there could have been some friction if it touched the sides. Both of these resistive forces will oppose the ball's downward force, which is this weight, yeah? So if you have a resistive force against the weight, the resultant force will be decreased, okay, and therefore the resultant force is what creates the acceleration. So the acceleration will be lower than if there was no resistance or no resistive forces. Now they want you to calculate the distance between the two light gates. Remember, he recorded the time and the speeds, but he didn't record the distance. And these are SUVAT equations, SUVA. We know them. The only one we don't know is T. So we have the final velocity in the data, we have the initial velocity in the data, we have the acceleration in the data, oh, and we got the time, but they want us to work out the distance. So you don't use the time, you go straight into the equation, which has these four letters, which is here as v squared equals u squared plus 2as. And that's the quickest way of doing it. So if you change the equation around, you can do the algebra first. S will be equal to v squared minus u squared over 2as. As long as you put the numbers in, you'll get the first mark. And then if you then change the subject to make S the answer, you get 4.2 squared minus 1.45 squared divided by 2a underneath, which is their value. Put the numbers in, you'll get either to three significant figures, that's 8.09, or round it up to two significant figures, which is probably accurate enough. You then get the first question complete. Okay? Here's the mark scheme. I'll stop the video and you can pause the movement of the page so you can stop the video and have a look at the notes provided. Okay? So that's what we just did. This is the most difficult equation in motion, and students often get confused. One of my students used this equation, which is not in GCSE, but is correct, and he did get the right answer, so well done. He must have done it in his maths. Okay. You can also do it by working out the average velocity between the two light gates, and then doing the kinematics, as it's called, the study of motion. Okay. Question 2 is about the first land vehicle to travel faster than the speed of sound. Okay, so it's shown in the picture. Needs a parachute to slow it down because the brakes probably won't. It will take a long time because if it goes that fast. Okay, it has a mass of 10,600 kilograms. Yeah, it uses 2 jet engines to produce a maximum accelerating force of 223 kilonewtons. Remember at the beginning of the test I said you need to be able to change units. If it's kilonewtons, you need to change it into newtons. However, kilograms is the unit we use for calculations, so you don't change kilograms into grams. So the equation that relates the unbalanced force, in this case the maximum unbalanced force, is equal to the mass times the acceleration. Yeah, so F equals ma, which is Newton's second law. And they want you to work out the maximum acceleration for when you have this maximum force. So the maximum force was 223,000 newtons times 10 to the 3 is 1,000, and divided by the mass, which was in kilograms. You keep that in kilograms, and when you do it to 3 significant figures, you get 21.0, and that approximates to 20 meters per second, and you have shown what they've asked you to do, which is to show that the maximum acceleration is approximately 20 meters per second. That would be to 1 significant figures. If it was 2, it'd be 21 meters per second. So remember, kilo then means 10 to the 3. Okay, so kilonewton is 10 to the 3 newtons. But we keep kilograms. Kilograms is the base unit for mass, whereas newton is the unit we use for force. Okay, here's the answers. Unbalanced force is mass times acceleration. Yeah, and then you can see that their calculation is shown like mine. Question 3 then is about wavelength. Yeah, you got to use a graph to measure the wavelength, and then they got another conversion of giga, which is 1 billion or 10 to the 9. Yeah, in the next question. And it's using the wave equation, if I remember correctly. So remember, gigahertz Giga is a billion, 10 to the 9 hertz. So question 3 is about microwaves. Yeah. And it's saying microwave oven cooks food. I don't think that's quite correct. It heats the food. I wouldn't call that cooking. Anyway, they want you to use this wave graph to work out the wave length, which is trough to trough or peak to peak. You decide which is easier. I think you'll find that the distance from here, the first graph, up to the end is the easiest way of doing it, because that's 1, 2, 3, 4 waves later, you get 50 centimeters. So 4 wavelengths is equal to 50 centimeters. So therefore one wavelength would be 12.5 centimeters. You put that in. So it says determine the wavelength of the microwave. It hasn't said how, but they mean using the graph, and wavelength, the symbol is lambda. So you could just do 1, but it's more accurate to do all 4. Okay? So distance between consecutive peaks or consecutive troughs is the easiest way of doing it. And since the graph starts with a trough, I would start from here. Okay? So 50 centimeters for 4 wavelengths, and this is given in centimeters. Yeah, there's your calculation. If you get it exactly right, you get 2 marks. If you get it slightly wrong, you get 1 mark. Okay, so the next question wants you to show that the speed of these microwaves is about the speed of light, 3 times 10 to the 8. They've given you the frequency as 2.3 gigahertz. That means 2.35 times 10 to the 9 hertz, because remember a giga is a billion, which is 10 to the 9. A million will be 10 to the 6. And then you've got to change your centimeters into meters. Okay? Once you do the wavelength in meters, that's the same. A centi is a 10 to the minus 2, giga is 10 to the 9. So both of these need to go with the number given. Put them in the equation, which is c equals f lambda, where c is the speed of light. And when you put the numbers in accurately, you'll get 2.9 to 2 significant figures. And to show that it's equal to 3 times 10 to the 8 to 1 significant figure. And that's how you should do it. Another question done. 5 more marks. Okay, question 4. Car is moving along a road. Again, it's looking at kinematics, which is SUVAT, S-U-V-A-N-T. You need to know what you're provided with. The initial velocity of the car U is 26. It then accelerates at this rate, 1.2 meters per second squared, reaches a final velocity of 35 meters per second, that's V. Okay. They want you to state the formula linking acceleration, change in velocity, and time taken. So change in velocity will be final minus initial, which is V minus U, divided by the time it took to accelerate. So the equation is A equals V minus U over T. Yeah, if you do it like I've done, make sure you show the examiner that you know the change in the velocity is V minus U and the time taken is T. You're meant to use word equations ideally, that you get 1 for that. Then they want you to calculate the time taken. Calculate the time taken. So they want you to change the equation round, and basically the T and the A swap places. If you know how to change the subject of the equation, put the numbers in, and you'll get 7.5 seconds to 2 significant figures, and you should really write it in here. And you'll get the 4 marks for knowing the equation and knowing how to change it around. The next one is about a radar speed gun used to measure the speed of a moving car, and it uses a Doppler effect. Okay, it tells you the speed gun emits radio waves, obviously towards the car. The moving car reflects the radio waves back to the detector, which is also in the gun. The detected waves have a different frequency compared to the emitted waves, and that change in frequency allows you to determine the velocity, although you don't need to for this question. This change in frequency, as I said, can be used to measure the speed of the moving car. But all you got to do is explain why is there a change in frequency. And remember, to get the marks, you need the correct amount of depth, detail, and clarity using the correct science terminology. When the car is moving towards the speed gun, where if it's moving towards the speed gun, and you've studied the Doppler effect, you would say, due to the Doppler effect, motion of the car towards the radar gun, the frequency of the reflected waves will increase. If you just state that, you get 1 mark and 2 marks for saying it's due to the Doppler effect. And why is that? Explain it. Because the wave fronts are squashed together. They become closer together as the car is catching up with its own reflected waves that it's sending back. Okay? They would not do this if the car was not moving. Yeah? So they're closer together than they would be if the car was stationary. So I just put that in for extra detail. And then closer wavefronts correlates with lower wavelength. Yeah, so lambda decreases in the wave equation where velocity is constant, because we know the speed of radio waves is known to be a constant, which is the speed of electromagnetic waves. And it's an air, so it's about 3 times 10 to the 8. So if the wavelength decreases, that means that's the reason why the frequency increases. And this is more than 4 ways of getting the 4 marks. And it's just the examiner will look at how many of the technical terms you used, how much depth and detail you've put in, and how clear your reasoning is to get the 4 marks. So here's the calculation that we did before, and they've given 6 marking points, yeah, that they are awarding marks for. Okay? If you don't know why it happens, but you just say frequency increases, you'll get 1 mark on its own. If you remember it's due to the Doppler effect, you get 2 marks on its own, and that's already half marks. So you're going to pass your GCSE if you can just get 2 out of 4. But it depends what you mean by what grade you need. Okay? Next question, question 5, is about a Van de Graaff generator. Should be DE, that should be DE, not DER. And the Van de Graaff generator produces very high voltages, about 6,000 volts, depending on the Van de Graaff generator. And the unit of voltage they're just telling you is the volt. They haven't asked the question about it. The question's been adapted for this test. And then they want you to state the formula linking energy, voltage, and charge. Well, charge is always Q, V is always voltage, and energy is transferred is joules. So whenever a charge moves through a voltage, you get an energy transfer, and that's what electrical energy transfer is. You get joules when you multiply the voltage by the charge in coulombs. Okay? So you could say volt is the joules per coulomb if you know how to put it as an equation. Energy is equal to voltage times charge. Charge is always Q, and Q is always measured in coulombs. So if you want to work out voltage, yeah, voltage would basically be joules per coulomb. Now joules is in, energy is in joules, and charge is in coulombs. So volt is the amount of energy you give to the charge. Okay, so this is a very important equation, and it's used quite commonly in A-level, quite often. This then says calculate the energy transferred to an electron, which is the main particle that's used for electricity, when it passes through 150 kilovolts of voltage. Remember, kilovolts, we've got to change it to 10 to the 3 volts. Yeah, and they're giving you the size of the charge of an electron. It's tiny, 10 to the minus 19 coulombs. So they're trying to see if you can use standard form. So if you multiplied the kilovolts, 150 of them, by 10 to the minus 19, there is no name for 10 to the minus 19. Okay, we kind of go down to 10 to the minus 15. I don't think there is one. At least I'm not aware of it. I've never used it. Multiply this together and you get the energy in joules to 2.4 times 10 to the minus 14. If you get all of the changes of the prefixes correct and the calculations correct, you will get your 3 marks. Okay. All right. So then they're using the same Van de Graaff generator. Yeah. And when it's fully charged, it stores this much charge. Remember, charge is Q. This time they want you to state the formula linking charge, current, and time. Well, that's Q equals IT. I is always current. Remember, I is not the same as A. A is the unit. Time is always in seconds. And coulombs we just covered. So I've put it as a triangle for you. Yeah. To help you remember, it says a charge on the generator discharges through the air as a spark. There's my spark. The charge, the spark, takes 0.68 meters per second to allow the charge to leave the generator. So time is 0.68 milliseconds, and a milliseconds is 10 to the minus 3 seconds. So again, they're testing to see if you change the prefixes. And once you know the time and the charge, you can calculate the average current or the mean current as the spark goes through the air. So I equals Q over T is the equation. I then started writing it the wrong way around before I corrected myself. Okay, put the numbers in. There's the charge in coulombs divided by time in seconds, changing milli to 10 to the minus 3, and you'll get 10 to the minus 5 in the answer, and the answer will be in amps. But they're giving you the units, so you don't get the mark for units. One for changing the equation round, and one for putting the numbers in correctly, and the third for numerically evaluating it. So remember milliseconds. Some of my students ask me, what does MS mean? Yeah, because of course M can also be confused with meters. It's not a meter second, it's a millisecond, so be warned. Okay, so another one you need to remember. Here's the answers. It's not actually question 7. It used to be question 7 in the original GCSE. Okay, so we handpicked questions for our students in year 10, the ones that they can do, because obviously until you're in year 11 you can't do all the questions. So here you'll see they give you a mark for converting kilovolts into volts. Yeah. And here, converting milliseconds into seconds is where you can drop marks. And here are all the prefixes you need for GCSE. Goes up to nano. For A level, I've also put that you need these ones underneath, the ones in brackets. Pico, 10 to the minus 12. Femto, 10 to the minus 15. Well, femtometers is the size of a nucleus. So that's the smallest object you will study in A level. And for GCSE, you just need to go to nano, so nanotechnology, micro, so you can see the letters. The ones which are less than 1 are lowercase, and the ones which are greater tend to be uppercase, except for kilo, which is lowercase. All right. Well, that takes us to the end of the test. I hope you found it useful. Don't forget to like, share it with any friends you've got doing GCSE. It doesn't matter what board you're doing. These questions will allow you to revise for your GCSE or your end of year exam in your school. Thanks for watching. Bye for now.